Good morning. Welcome to Physical Science in the AM. I am Joel Shadelka, and we've got solution strength to look at. Okay, so we've been dealing with moles, and we talk about moles because we don't want to talk about one atom or one molecule at a time. So solution strength, you guys would never have really come across this outside of a chemistry classroom, so you haven't come across this. Molarity is what we call it. Now, solution strength you may have heard about, though maybe at a percent. There's a purpose to that too. So solution strength, you have an idea of that. Like if you make iced tea, something like this with powder or whatever, Good Host or something like that. You know if it's, oh, this is weaker than the last time I made it, I need another scoop of mix, right? So you guys get the idea of what we're measuring, how much is dissolved in. Now the vocabulary and concentration is given in molarity. Well, that's going to be moles of solute dissolved in the solvent. Now, first of all, solute and solvent are words you don't use a lot. You've probably heard the word solvent. So, people often think of a solvent like if you get oily hands or whatever, like you ever hear people like how to get oily clothes and stuff like this, dissolve it in a solvent or something like this. Have you ever used the word solvent? Okay, you two have. Has anyone else ever heard the word solvent? Yes. Either one of you at the back. Any vague notion of what a solvent is? Okay, fair enough. Okay, that's common. So, water is the most common solvent. That doesn't tell us what. Not at all. Well, kind of in this way. But the solute is what you're dissolving in the solvent. We will stick to water in all of our calculations. So water does the dissolving, it's the solvent. And like if I was talking about making powder, like using a powder to make iced tea, the solute would be the iced tea mix, right? So basically sugar. If you're taking a teaspoon of salt and putting it in a cup of water, the solute is the salt, NaCl. Does that make sense? So solute is what you're dissolving in the salt. Okay? Now, the units in molarity, and that's what's important for chemistry because it gives us a ratio of, or it tells us basically proportionally to the other things, how many atoms or molecules there are compared to other things. Moles of what you're dissolving divided by the liters of the solution, and it'll be a water-based solution, so it's always equals. And we can abbreviate with a capital M. Never use a small m because that means meters in science. But I actually quite often though write it out as moles per liter. And I'll just put that over here. That way I can see what crosses out, how we've been showing crossing out for units. So in the question, I'll often give a capital M, but when I do my work, I'll use moles over liter. Okay. So I've got this example here. HCl, because you've probably heard of it, hydrochloric acid when it's dissolved in water. It's actually a gas. But anyways, you can dissolve gases in water, right? What do fish breathe? Air, well, oxygen. But it's oxygen that's dissolved in water, right? That's why people they have a large number of fish, they'll have a bubbler on their tank to just get more dissolved air in there, and it's the oxygen that they get. You know that gases are dissolved hot. When it's pressurized, especially, you've got carbon dioxide dissolved in water, right? That's essentially it. Yeah. Okay. Well, in this case, HCl molecules would be the solute, water is the solvent. And I just have that picture there just to kind of remind us things. Okay? So, how about this one? NaOH, that's sodium hydroxide. A solution of sodium hydroxide has 19.2 grams of solutes, that's sodium hydroxide, dissolved in 160 mils of a water-based solution. We're always assuming it's water. Yes. Second. Okay, got your sheet. Anyways, so let's work through this. See what we get. How do we solve one of these? We need moles and then we divide by liters. So, a few things. We need moles of the sodium hydroxide. So I see this and I think I need moles. So I'll write down in green what I'm thinking. Need moles. So what I'm thinking is I need moles. So I'm going to start with that single item that's not a fraction. 19.2 grams of NaOH. We already have the skill how to get to moles. We'll go through it together. So if I want to go to moles, I want to get rid of grams. So I put a G on the bottom, 1 mole on the top. I use the periodic table, which you guys see today, most days now. And I add up. So I'm going to do it on my calculator. Na plus O plus H, these are all single items. So 22.99 plus the O, 16, plus the H, 1.01. Comes up to 40, but I'm going to put down decimal 00. That's how accurate I was measuring. 4 significant digits. I only have 3 significant digits in here, so when I calculate it, I'll keep 3. So I'm going to go with, we know how the math works. Anything on the bottom is dividing. So 19.2 divided by 40. And I've got 0.48 is what shows up on my calculator. But I'm going to put down a 0 because I know it's accurate to 3 significant digits. It's not decimal. And that is now, grams gone, moles. NaOH. Okay. I've got the first part. The second part is fairly easy. I got to take the moles and divide by the liters. Here's what I'm thinking. I need the liters of solution, but I got mils. Now, this classroom is pretty small, but I'll always tell you, there's 1,000 mils in a liter. You probably know that because it's 1,000 millimeters in a meter, 1,000 mils in a liter. It's the metric system, so it's repetitive, right? 1,000. You can divide by 1,000 in your head usually. I don't want to use a calculator, go ahead. A lot of mils is a smaller amount of liters, right? So you always know I got to divide. And when you divide, it's just moving the decimal 1, 2, 3. So I can do that in my head, right? I'm going to jot that underneath, but I wouldn't normally. I'd go, okay, 0.160 liters. That 160 is important because I'm going to assume that that 0 on the it's actually ambiguous. There we go. Okay, so we're going to take this. There we go. And here's how we do the final calculation. So we say we're going to take concentration in molarity. The moles of solute dissolved in the solvent. So the molarity. In this case, there's a standard in chemistry. To label the chemical, you actually just say square brackets NaOH. That means I'm giving it molarity, concentration. So, if you do that, and that's the correct way to do it, you don't have to put the NaOH after you calculate every other time. Let's say the sodium hydroxide's concentration is equal to, that's the square bracket. And then I take the moles that I calculated, which I'll write it in the same color so you know where it comes from. 480 moles divided by, and we said it's 0.160 liters. Now you could argue that it's only 1/6, or it's only 2 centimeters. And I'm fine with that. That would mean your answer only is 2 centimeters. So it's just a division problem. I can take it, divide it by 0.16. And I've got 3 bang on. But I'm saying that I have three significant digits, so I'm going to say it's three, not three-ish, it's three. Now, two ways to give the units. I could write down mole over liter as my unit, or I could write down capital M, which stands for moles over liters. I'm going to put the capital M down just to get used to both. There's the first example. So we really just need our grams to moles. That's really the skill that we go there and just divide our liters. Of course, I gave you the first example of simply how this works. That's how this works in math and science classes. The teacher gives you the first example. 3 plus 2 is equal to 5. Now it's your turn, and it'll be like Jeremy drank 7 Coke Zero this week, and he bought them at the grocery store, flat of 12. How much did he spend on Coke Zeros? Okay, yes. And then when it comes to the test, the question is, no information given. What is the mass of the sun? Isn't that how it works? Yeah. Yeah. Okay. Well, here we are. Here's my how many Cokes did you drink? Not quite, but I'm exaggerating. That's the way sometimes you feel as a student. This one's working backwards. How many grams? I could have said, what is the mass of HCl? And 150 mils of a decimal 300 molar solution of HCl. So this is same measurements, but we're working backwards. So before we start calculating, maybe I'll just even, at least in my head, think this through a little bit. This is in mils. I want it in liters. So I can divide by 1,000 in my head and just move the decimal 2 times. That's how many liters we're going to use in our calculation. So I don't normally write this down, but I'm teaching you this. I am. This, I'm going to write down. I do this in my head, but this is what I think when I see this number. 0.300, and the big M stands for moles over liters. So I'm going to actually write it down as moles over liters. So keep that in mind. That's what the big M stands for. Okay? And it's a fraction, meaning I might have to flip it. In some cases, I need liters over 0.3 moles, or else 0.3 moles over 1 liter. Okay? We want grams. This is like a two-step calculation. Here's what we're going to do. We're going to start with the single item that's not a fraction. I keep saying that again and again. They're all different. I'm going to start with 150 mils of the HCl solution. So I'm going to write down, not 150, 0.1500 liters. Now I'm going to put down that it's HCl. Right? Now when we had two-step conversions the other day, I got a test yesterday, it was more than yesterday. It said, usually, get moles with your first bracket. There you go. I want to get rid of liters, though. Basically, as a starting point, if you have liters or whatever you start with, put it downtown here, and that's what you want to get rid of. Can I get to moles? I don't eventually want to end up in grams. Well, yeah, I can. In this case, I'm using my concentration. I didn't write down the 1, but it is a 1 per liter per 1 liter. I'll put it in this time. Now that's a defined 1. That's not a 1 significant digit. That's what molarity is defined as. 1.00, as many zeros as you need to make it exact. But I'll put in the decimal, right? 300. So everybody knows where that came from. And I stopped calculating, I wasn't. Right now, I would have the moles of HCl. You could, and then write that number down and go on. But we have the skill, we're going to work on the skill, two-step calculation. I don't want to end up with moles. I want to stop and get grams. So I want to get rid of moles. Here's grams. So I know the periodic table. If I say 1 mole weighs however many grams HCl, and I keep going to look at it. Grams. 1.01 for the H plus the Cl, 35.45. 36.46. Okay, there we go. At this point, I've gotten rid of moles, and I do end up with grams, and that's what I want. Okay? Mark-wise, I'm giving you 2 marks for this set, one for each bracket. Third mark is for the answer with the correct deal. So everything's on the top. It's only one's on the bottom, so it's all 0.1500 times 0.300 times 36.46. I get 1.6407. That's more digits than I need. 6407. So what I'm thinking is I need 3 significant digits because this one has 3 significant digits. Everything else was 4. So 1, 2, 3. I'm going to write down 1.64. And that is now in grams, and the chemical is HCl. There's my third mark. Any questions there? So this is how much each coat costs when you drink 7 in a week. Now the weight of the sun. Third one. The top. According to teacher patterns. What volumes? 3 moles per liter sodium hydroxide solution is required to obtain the grams. I've been given the grams. 47.1 grams of that sodium. Okay. Let's backtrack. I know that this moles 3 means is what I'm doing in my head. Moles per 1 liter. I can do it that way, or I might be able to flip it. If I have that in my head, though, I realize it's a fraction. Volume. What is volume measured in? Liters. Okay. So the liters is what I'm trying to find. That's what I'm thinking of. And I write down the single thing that I'm given that's not a fraction. Typically, that's how you start. The odd time you'll have something different. Okay. I wrote down my measurement. Most often, what do you do in your first bracket? You get rid of what you got and probably get moles in the middle, right? Like the middle bracket, first bracket. So I'm going to get rid of grams, and I'm going to use the periodic table to figure out the grams in a mole of sodium hydroxide. We actually did that earlier on the first page, right? 40.00. I added up Na plus O plus A. So saved us some time. Okay. The first bracket, I've gotten rid of grams. So always get rid of what you start. There's no formulas needed in chemistry for most calculations this level. You just mix and match them. So if I start calculating right now, I would have moles of sodium hydroxide, right? And I could do that, but I don't want to stop there. I want volume, liters. So my next bracket, I say, I want to get rid of moles, and I want to keep liters. I need a fraction that has moles and liters, conversion ratio, and I happen to have one. I have concentration of 8.00 moles per liter. That's what I wrote down as a fraction. This time, though, this is one where I have to flip it. I put the 1 liter on there and the 3, and that came directly from this, right? That's the big M. I can flip it. And if I I stopped calculating right now, moles would be gone, and I'd be left with liters, and the chemical is sodium hydroxide solution. So 40 and 3 are both on the bottom, so it's both division. So I use my calculator, 47.1. I can't do that. Divided by 40, divided by 3. I've got 0.3925. Okay, I'll write that down. 0.3925. I want to keep 3 digits because that's the smallest amount of significant figures in the number. That 2 becomes, it rounds out to a 3. 0.393 liters, and that's sodium hydroxide. I can tell you this, most likely, if I used to graduate cylinders and stuff like this, I'd be measuring in milliliters. How do you go back from liters to milliliters? Times 1,000, right? It'd be 393 milliliters. Okay. A Coke can, by the way, is about 355, so it's a little more than that. It's not a lot. Okay. So, doesn't surprise you. I've given you basically the 3 types of questions you can get. Find volume, liters. Find moles or grams. Actually, I didn't do one that's just short. Each one of these, I could have stopped at the red and just found moles, right? And then find the actual concentration where I do the moles as a separate problem and then divide by the liters. So, in this case, I want you to calculate the molarity. That means what's the moles per liter. This one, it gave you grams, so you're going to have to convert to moles. This one is simpler because I already have the moles, and I just divide by the liters. 500 mils is 0.5. Number 2, how many moles? So this is where I would stop with the first bracket. That big M means moles per liter. How many moles? Liters. Okay. And then how many grams? So there's some practice questions. They're actually a little shorter than the example. I gave you the mass of the sun questions. Now I'm just asking you to say what's true, what's true. Go for it. These should be done in the classroom. I'll pause the video. So the first few, 1A, I'll go into explicit detail here, how to do it. Calculating the molarity of the following. I start with the given thing. I want to get molarity. So I need moles, and then I divide by liters. So I start with a single item that's not a fraction. Grams. MgCl. I've always said I'm looking for this in your work. Labeled as a chemical, like the unit in the chemical. And then I want to get rid of grams. I want to get to moles, because they're going to go moles divided by liters. Okay, Mg plus 2 groups of Cl. I'll look it up on my periodic table, 24.31. Plus 2 times 35.4. I get 95.21. Stop me if I make a mistake, because I'm doing them fresh and I make mistakes. Okay. So 0.963 divided by 95.21. I get 3 significant digits. 0.0101. That's the mole. Then the next thing I do, I only change color because it's a different step, is say that I want molarity. So I'm going to put this in square brackets, MgCl2, because I'm reporting a molarity. I'm going to take the moles. Divide by liters. And that was given in liters, so 1.50. Do this. Now, I want three significant digits. What I wrote down is 0.00, after 0.00673 moles per liter for big N. Now, I'm going to mention something, and I will give 100% for this as well. If you left that first number here in your calculator, you would have had on your calculator 0.0101144838. If you left that in your calculator, I often do, and I just hit divide, because it's already in my calculator, by 1.5, I would have gotten 0.00674. And I would definitely get it. So I'm going to just only do this in green because it's not needed, and it's 100% correct. Now, I'm not going to be too sticky because I know that's actually just as valid, and it's actually probably better because I only rounded at the last step. But I'm not going to make your life miserable if I choose to do it this way or that. Okay, so I would accept either answer proper. Okay, but I only did it in green because you don't need it. Now the next one is a little bit easier because I already have the moles, and I got to take the moles and divide by the liters. I can do that part at 0.5. So this one's kind of easy. MgCl2 again, but we already have moles, so no need to do any conversion. So I'm going to take the 0.500 moles, divide by 500 mils, but that's 0.500 liters. I can do this one in my head as one. But it's not just one, it's one of three significant digits, 1.0. I'm going to put the big L. A 1 molar solution. It's quite common in my, I'll just bring out the chemical here, I'll just show you. So I just wanted to show you, I actually do label my chemicals. And this is like 2 molar HCl, 2N. I even, just because next time I do these calculations to figure it out, but I do these calculations so often, it's like, why am I doing this? So I actually write down how many mils, 83.3 milliliters of 12 molar HCl for each 500 mils of, like, I do these calculations. So if you're a chemistry teacher, you do this all the time. This solution I have the grams for 500 mils here that I have to measure out, and it's 0.03 moles per liter. This kind. So I'm just showing you that there's, if you're a chemistry teacher or you're at university, there's a practical reason to do this if you're studying chemistry. Yeah, everyday science, you don't do these kind of things. Classroom science, you do. Okay, calculate how many moles of HCl are in 50 mils of this 13 molar solution. Okay, I start with the given item that's not a fraction. 50 mils, I'm going to do this one in my head. It's 0.0500 liters, right? That's 50 mils. And it's HCl. I know I want to get rid of liters, and I want to keep moles. And I'm going to just stop there. Moles, liters. And I know that this big M stands for moles per liter, so I just put it as 13.0 moles per liter. That's a multiplier. So, 0.05 times 13. You know what? I just realized I created a question that's actually not practical. I'll explain why. 650 moles of HCl. Now here's what I'm saying. You wouldn't have known this, and I wasn't thinking when I was typing this up. I was just randomly putting in numbers. HCl, the strongest HCl I buy is 12 moles per liter. I'd never get a 13 mole per liter solution. It just can't hold that much gas. Anyways, but mathematically it's all fine. Okay? This one here is realistic though. How many moles of sodium sulfate and 1.5 liters? Okay, it's already in liters, no need to change it. And I've got the concentration in moles per liter. So that's good. So I'm going to start with the 1.5 liters of not H2SO4, Na2SO4. I want to get rid of liters, and I know that it's 0.20 moles per liter. I thought I'd write it this way with moles per liter instead of big F. Same thing. 0.20. And 1 liter. And then once again, I multiply 1.5 times 2. I get 0.3. Liters are gone. But I need to add a 0 for 2 significant digits. And that's moles of sodium sulfur. Okay. How many grams? The last one. Calcium chloride. How many grams of calcium chloride? So I need to go to math. This will be 2 steps. Starting with 250 mils. So that's 0.2 liters. I'm going to assume that that's pretty significant. I know for sure it's at least 2, so I could write that down. Okay. But I'm telling you 2, though. You can assume in my class that that'll work. Okay. Liters. 2 moles per liter. Okay, I write it down exactly like that in moles. What do I want to get rid of? Liters. If I stop now, I would have moles. I want to get grams. So I'm going to go with grams on the top, 1 mole on the bottom. I use the periodic table to figure out the grams of Ca plus 2 Cls. 40.08 plus 2 times 35.4. 110.98. Everything's a multiplier. 0.25 times 2 times 110.98. 55.49. I can only keep 3 inches. So 55.49, I'm going to make it 0.5. Yep. 55.4. Calcium. Now, finished up just in time. I'll pause the video or stop the video and ask you guys a question or two.